Hi lads, just a couple of you gotten on to me in regards to complex numbers and asked me could I do a video. So what I'll do is I'll do a video of your homework that I gave you earlier on in the week that I posted solutions on Edmodo. Okay, so let's have a look at them. Okay, so this is a homework I think I gave you Wednesday and I gave you the solutions on Edmodo. So I'll leave the other ones so you can work over the weekend, alright? So you can see here this is question 2. Okay, and there's A part 1. So question 2, A part 1. Okay, and the first thing it says here, lads, is the complex number Z1. Okay, so they give you Z1. Okay, and Z1 is equal to 2 plus I. Okay, and as you know, I squared, no harm writing it here I suppose, okay, is equal to minus 1. Alright, and they do give you a bit of an Aragon diagram over here. I'll just do a quick little sketch of it. Alright, try and make that a little bit straighter. Okay, so that's the real axis, as we know, and this is the imaginary axis here. Alright, and it goes up in 1, 2, 3, 4, and now as far as 1, 2, 3, 4, 5. Okay, and Z1 is 2 plus I. Okay, so they've plotted over here. Okay, and that's your Z1. Of course, I might as well label these. Okay, so the first part of the question, as I said, is Z2 is equal to 2 times Z1. So Z2 is equal to 2 times Z1. Okay, and it says find the value of Z2 and plot this on the diagram. Okay, well Z2 is equal to 2 times Z1, but Z1 is this here, that's Z1 there, it's 2 plus I. Okay, so it's 2 times 2 plus I, which is equal to 2 by 2, which is 4, and 2 by I, okay, which is 2I. Okay, so that's Z2. So with a different colour here, lads, I'll use green, I can plot Z2. So it's 4 on the real axis, okay, and it's 2 on the imaginary. Okay, so there you have Z2. Alright, so there's your Z2. Now, the next question then. Okay, it's part A part 2. I'll just scribble it down here. So A part 2. Okay, it says Z1, okay, with the line across, as we know, is a conjugate. Okay, so Z1, okay, is a complex conjugate of Z1. Write down the value of the conjugate of Z1 and plot and label it on the Aragon diagram given to us. Okay, well we know up here, lads, that Z1, okay, is 2 plus I. And to get the conjugate, you simply just change, okay, you just change the middle sign, or the sign of the imaginary number. That's all you got to do. Alright, so back down here then, lads, you have 2 minus I. Alright, and that there then, lads, is your conjugate of Z1. That's simple. Now they want me to plot this on the Aragon diagram, so I need to go down into my imaginary, down here into the negatives. Okay, so that's minus 1, minus 2, minus 3. Okay, again I'll use a different colour, I use yellow this time. Okay, and 2 minus 1, okay, it's just kind of covered there by that 2, but it's that point there. Okay, it's 2 on the real and minus 1 on the imaginary. Alright, so that there will be the conjugate of Z1, that point there. Alright, now part 3 gives us an investigation. Okay, so this is A, part 3. Okay, and it gives us an investigation. It says investigate if, now that's the mod of Z2, okay, is equal to the mod of Z1 plus the conjugate of Z1. Alright, now we know Z2, okay, from back up here. Z2 is this here, that's Z2. Okay, and they want the mod of that. Alright, so the mod, if you remember, lads, is simply the square root, okay, of the real part to be squared plus the imaginary part to be squared. That's the mod, okay? This will be equal to the mod of Z1 plus the conjugate of Z1. Okay, in order to get that, okay, z1 plus the conjugate of z1. I'm going to scribble it over here and do it out before we go into the modulus. Okay, so z1, as we know, given to you in the question at the very start, was 2 plus I plus 2 minus I, because that there, lads, was the conjugate. Okay, now remember it's real with real, so 2 plus 2 is 4. Okay, and I minus I is of course 0. So we have no real part, or excuse me, no imaginary part of that complex number. So to get the modulus, it would be the imaginary, or sorry, the real part squared, which is 4 to be squared, okay, plus the imaginary part squared, which is 0 to be squared. Okay, let's tidy them up. 4 to be squared is 16, and 2 to be squared is 20, so that's the square root of 20. Okay, and 4 to be squared is 16, plus 0 to be squared is 0. Okay, so we can safely say, lads, that these are not equal to each other. Alright, so it's not equal to each other. So you can put a line through the equal sign there. Okay, and that's A part 3 done. Now, the next question then, lads, or the last part of this question is B. Okay? And this might be a little bit trickier, obviously, okay, because this is a hard part to the question. So you're looking at B, okay, and it says that show that Z1, now as we know, Z1 is equal to 2 plus I, okay, is the solution of the equation Z squared minus 4Z plus 5 is equal to 0. Okay? So you have to show that that's a solution to that. Alright? Now the only way you can show that this is a solution, lads, okay, is to substitute in Z in for Z in the equation. And if the left hand side equals the right hand side, well therefore it satisfies the equation. So what do I mean by that? Well, if we write out the equation, which is Z to be squared minus 4 times Z, okay, plus 5 is equal to 0. Instead of writing Z, okay, so we have Z here and we have a Z here, let's substitute in 2 plus 1, because that is technically Z. Okay, so Z to be squared will be 2 plus I to be squared, bearing in mind, we know what I squared will be, minus 4 times 2 plus I plus 5 is equal to 0. So if this left-hand side of the equation equals 0, well then it satisfies this equation, or is a solution of the equation, because it obviously equals it. So let's multiply out 2 plus I to be squared. I'll do it over here for some of you that might be a little bit, or struggle with this, or a little bit unsure of it. So 2 by 2 is 4, 2 by I is 2I, I by 2 is 2I, and I by I is, there we have it, I squared. That's going to be 4 plus 4I. We know what I squared is, it's minus 1. So it's going to be 3 plus 4I. Okay? So, we have 3 plus 4I minus 8, because minus 4 by 2 is 8, and minus 4 times I is minus 4I. We have a 5 out here. Okay, that plus 4I cancels that minus 4I. 3 minus 8 is minus 5. Okay, that's a plus there. And minus 5 plus 5 is 0, so 0 equals 0. So because, okay, they equal each other, we can say it is a solution. Alright? So that's that first question there, lads. Okay? Hopefully you found that helpful. So then the next question I gave there was a 2018 question 2, I believe. Okay? So again, I'll do this out for you. So this was the 2018. You can be sure that these will come up, lads. They come up every year. Okay, so what does it say first before any questions is given to us? Well, I'll just write them out here for you. So Z1 is equal to minus 2 plus 3I. Okay. Z2 is equal to minus 3 minus 2I. Okay. And I just split this up with the commas. And Z3 is equal to Z1 minus Z2. And saying that I squared is equal to minus 1. Okay, so it says plot Z1, Z2, and Z3 in the diagram. Yeah. Okay, and label each point clearly. Well, Z1 and Z2 will be easy enough to plot. Okay, but Z3 I need to do a little bit of work. So Z3 is equal to Z1, which is minus 2 plus 3i. Now be careful that minus here because it's minus Z2, which is minus 3 minus 2i. Okay, that's minus 2 plus 3i. Minus by minus 3 here is a plus 3. And minus by minus is also plus 2i. Okay, tidy that up. We've got minus 2 plus 3 is 1. And 3i plus 2i is 5i. So that is what Z3 is. Okay, so now I can sketch an Argand diagram. Okay. And we've got 1, 2, 3, 4. 1, 2, 3. 1, 2, 3, 4. And then up as far as 6. 2, 3, 4, 5, 6. Alright. So let's just number these off. Makes it easier. We're going to be plotting the points. Alright, so let's plot our points. First one there, Z1, is minus 2 on the real axis and a positive 3 on the imaginary. Okay, so plot, and it did say label, so that's Z1. Okay, Z2 is minus 3 on the real, okay, and minus 2 on the imaginary. Okay, so that there is Z2. Alright, just get rid of this down here. Okay, and then Z3 is 1 plus 5i. Okay, so there's Z3. Alright, and that's the first part of that question taken care of. Sorry, I should label that there. That's A, taken care of. Okay, now it says investigate if the mod of Z3, I can squeeze this in over here. So it says investigate if the mod of Z3, okay, is equal to the mod of Z1 plus the mod of Z2. Okay, now square root. Okay, again, look at Z3 up there, it's 1 plus 5i, so you're going to take the real and square it, and add it to the imaginary and square it. Z1, take the real and square it, and take the imaginary and square it, and then they want you to add that to the mod of Z2, which is take the real number and square it, and take the imaginary number, and also square it. Alright, so got 1 to be squared, which is 1, and 5 to be squared is 25, so 1 plus 25 is 26. Okay. Minus 2 to be squared is 4, and 3 to be squared is 9, so that's the square root of 13. Minus 3 to be squared is 9, plus 2, minus 2 to be squared is 4, so once again that is root 13. Okay. Now, if you want, you can check your calculators, but a lot of people will jump to the conclusion, gentlemen, okay, that root 13 plus root 13, okay, is equal to root 26 would be incorrect, okay. Root 13 plus root 13 gives you 7 point something or other, okay, where root 26, okay, gives you 5.09, okay. So therefore, it is not, okay, it is not equal to root 13 plus root 13, okay. Alright, I suppose if you wanted to, not to overcomplicate it, if you wanted to tidy that up, it's 2 root 13s. Okay, but they're not equal to each other. Okay, so that'll be your conclusion, okay, not equal to each other. Alright, so you're on to the last part of this question here, lads, okay, is where you have a division of complex numbers. Alright, so this is part C. So it's saying Z4 is a complex number where Z1 divided by Z2. Okay, well that doesn't seem too bad. So Z4 is equal to Z1. Okay, and we know from previously on the question that z1 is minus 2 plus 3i, and z2 was minus 3 minus 2i. Alright? Now, the thing about complex numbers is it can't be a complex number if they're divided. And this question gives it away anyway. They want it in the form x plus yi, where x and y are elements of the real numbers. Now, if you remember, okay, if you want to get rid of this fraction, you divide above and below the line by the conjugate of the bottom complex number. So the bottom complex number is minus 3 plus 2i. So you want the conjugate of that. The conjugate of that, if you remember from early on, was minus 3. You change the sign of the imaginary number. So you change that minus 2i to a plus 2i. Okay. And now what you're left with, lads, is you multiply out the top line. And you multiply out the bottom line. And let's see what happens. Okay. I suppose leave it in red here. We're going to go minus 2 by minus 3. Then we're going to go minus 2 by a plus 2i. So let's do that first. So minus 2 by minus 3 is going to give me positive 6. And minus 2 by a plus 2i is going to give me minus 4i. Alright? And then don't forget, I'll use a different color here if you like. You've got to multiply the 3i by the minus 3. And you have to multiply the 3i by the plus 2i. So 3i by minus 3 would be minus 9i. And plus 3i by a plus 2i is 6i squared. Okay, let's do the bottom line. Again, minus 3 by minus 3 and minus 3 by 2i. Let's do that first. So minus 3 by minus 3 is going to give you positive 9 as a minuses will become plus. And minus 3 by 2i, okay, is minus 6i. Okay, again, change to yellow. Minus 2 by minus 3i, sorry, minus 2i by minus 3, and then minus 2i by a plus 2i. So minus 2i by a minus 3 gives us a plus 6i. And then minus 2i by a plus 2i, okay, will give us minus 4i squared. Alright, so tidy these up if you like. Okay, I'll just do them over here. So the top line will give us 6. Okay, minus 4i minus 9i is minus 13i. And that's going to be plus 6 times minus 1, because I squared is, of course, minus 1. Down the bottom line, you can see that minus 6i, that plus 6i will cancel each other out. So you've got 9 minus 4 times minus 1. So let's work our way down here. That's going to be 6 minus 13i, okay, minus 6, okay. And then down below here, you're going to have 9 plus 4. Okay, 6 minus 6 is 0. So you're going to have 0. Okay. Minus 13i. Okay, all over 13. Okay, 0 divided by 13, okay, is of course 0. Alright, so you're going to have 0. And 13 divided by 13 is 1, so minus I. Okay, now remember, they wanted it in x plus yi format. So you can see x is your 0, okay, and 1, okay, would be your y in this question here. Okay, I suppose if you wanted, you could put in that 1 there if you wanted. So it's 0 minus 1i. Alright, lads, that was the solutions, obviously, that I already posted to you but hadn't given you a video of it. If there's any other videos that you want me to, lads, just let me know. I'll let you work on those other questions I set for homework over the weekend. I'll get back to you early next week. Alright, lads, enjoy the rest of your weekend.